Here is where we get to mix operators. Now again, the grammar is very small. Again, we're still just doing addition, multiplication, and parentheses. That's it. Okay. Matter of fact, in this example, we're not doing any parentheses at all. We have A equals B plus C times A. But as you know, this time, without parentheses, we should still be able to have our C times A comes first if the grammar is good. If it's not, then we're in deep doo-doo. And then whatever the product out of C times A happens, then we'll go ahead and take care of B and then put it into A. Now, to be honest with you, I'm not sure why I show you a derivation of it, but I'm not going to worry about that. But I really want you to go ahead and draw the parse tree for both of these. Now, notice I'm saying left parse tree and right parse tree, meaning leftmost parse tree. I'm going to change that, matter of fact, in the notes. And then rightmost parse tree for the other one. So go ahead and do that, and we'll compare notes after that. So if we did it right, they both, left and the right, should end up like this. That's good news. That means that that grammar, so far that we've tested it, is not ambiguous. It's not greedy. There's no sparseness to it, whatever. They both end up to be exactly the same. And again, let's take a look at it in depthly here. Is that number one, we have the multiplication sign. Out of all the other signs that you see, and again, there's no parentheses in this example of A equals B plus C times A. That's the lowest hanging fruit, and it should be, because that's what we needed to complete first. Then comes the addition, and then the equal sign happened to be last. But think about it. It's using an assignment, so that's going to be last and done, so that's fine. Okay? But that's how that's going to work out. That's how we want it to work out. If we wanted to start adding other symbols to this, like division, square root, all these other things, we're going to, number one, obviously the grammar is going to have to get much more complex. But again, in our design, we got to make sure that, power is usually a highest priority. We need a lot of productions to get to power, but we got to go through all of the other options before that, like subtraction, division. What else is there? There's a whole bunch of other things before we get to power, but we need to cover all the lower hanging fruit first when it comes to production, then get to the intermediate, and then get to the ones that are high priority. But notice I'm going top to bottom here because, well, frankly, that's how we would write it in the grammar. And it's also that way when it comes to the tree. The items towards the top are of a lesser priority when it comes to mathematics. Except for those that are hanging much, much deeper, they'll have to come first, as we talked about ad nauseum now.